Hello guys, welcome back to our YouTube channel. In this video we are going to discuss an important topic called wound healing. So it is a response to injury in an attempt to restore the normal function or functions. So there are two mechanisms involved. The first one is regeneration and the second is repair. Now we're going to discuss regeneration. So it occurs by proliferation of parenchymal cells. When 60% liver is removed, the remaining protein have the ability to regenerate. Now we are going to discuss the second mechanism, which is repairing. It occurs by the formation of connective tissue or fibroblast that leads to scar formation or fibrosis. So regeneration and repairs depends on the types of cells in that area. For example, if the injury site contains labile cells such as epithelial cells, so these are continuously dividing cells. So they will adopt regeneration mechanism of wound healing. If the injury site contains stable cells and stable cells in low proliferating state, for example, when they are stimulated, they will convert in highly proliferating phase and convert into G1 phase. Cells of pancreas and liver are examples. If the injury contains permanent cells, they are not dividing cells, so they will promote repair mechanism of wound healing. Wound healing also depends on the injurious stimuli in case of severe and persistent injury repair mechanism. Separation is dominant as compared to regeneration mechanism, for example cells in neurons and cardiac muscles. Now we will move towards the chronic inflammation. In chronic inflammation, tissue injury and tissue repair mechanisms continuously occur together. Role of cells. The first cell is macrophages. There are two pathways for the activation of macrophages. The first one is classical pathway. So classical pathway is included by interferon gamma released from T lymphocyte. Additionally, classical pathways induced by bacterial products cause activation of toll-like receptors. Metal crystals are also responsible for the activation of classical pathway. So it is a result of classical pathway macrophages become activated. It become M1 macrophages. These macrophages will produce more reactive oxygen species and upregulates the activity of lysosomal enzymes. These M1 macrophages release some enzymes like interleukin 1, interleukin 12 and interleukin 23. Thus will promote inflammation. Now we will move towards the alternative pathway. It is induced by cytokines such as interleukin 4 and interleukin 13 that are released from T lymphocytes. As a result, macrophages become M2 macrophage after the induction growth factor activates, which are responsible for angiogenesis. These M2 macrophages also produce collagen and continue tissue repair mechanism. These macrophages also produce some certain cytokines like interleukin 10 and tissue growth factor. Now we will move towards the second type of cell, which is lymphocytes. Lymphocytes participated in the cell-mediated and antibody immune response. So lymphocytes are basically of two types, B lymphocytes and T lymphocytes. In tissue, B lymphocytes differentiate into the plasma which produce antibodies, and T lymphocytes, specifically helper T lymphocyte, participate in inflammatory response. So there are three types of T cells, CD4. So Th1 release interferon gamma that is responsible for induction of classical pathway for the activation of macrophages. Th2 cells release interleukin 4, 5, 13 which will recruit the eosinophils and induce the alternative pathway for the activation of macrophages. Th17 cells will release interleukin 17 which cause induction of release of more cytokines. So this is all about today's video. I hope this video will be informative for you. Thanks for giving us your precious time. Please like, comment and share this video and subscribe our YouTube channel.